Hello, programming students. How are you today? I'm just going to spend a short time with you on the video going over what you're going to be looking at this week related to debugging and error resolution using AI. The first 3 weeks, we've really just been exploring and doing different trial and errors with the AI and just getting familiar with the tools. And then I do have a project that will start a little later this week. I don't quite have it done for you, but I should soon. And I will post another video kind of describing that project, and then you'll get to work on it for a week or two. And then next week, we're going to look more specifically at databases and how AI could be used to help with the tasks that we have to do when working with databases in MySQL or other SQL systems. And then later, we'll look at web development specifically as well. But today, this week, I want you to do a little more exploring with AI, but specifically related to how it's used with debugging and error resolution. So the assignments I have for you so far this week are to look at this presentation, which I'm actually going to go over with you right now in this video, but then we'll have an AI debugging lab that you'll complete, and I'll introduce that in today's video as well. And then you'll have a short quiz over some of this material. Later in the week, like I said, I do have a project assignment coming up, and I'll have a journal reflection added. The journal will likely still be due on Sunday, but the project will span a longer time period. Let me go ahead and spend some time looking at this PowerPoint with you. So as I said, we're going to be looking at AI tools and how they can be used to help you with debugging or just resolving errors in your program. And so debugging, as I'm sure you know, if you've had any programming course at all, is a big part of programming. And it's something that you get better at over time, but you definitely need to learn lots of tools and tricks for being better at debugging because it is one of the most time-consuming parts of programming. And what a lot of beginning programmers do especially is just random things to try to figure out their errors in their program. They'll stare at it, they'll just trial and error, do different code. Then they might do some Google searching or eventually ask for help. But look at, I love this little graphic here that I found. It said that for debugging tactics, I've tried all of these, see if you've tried all of these, but this is a great little comparison as to how often I might try a specific tactic versus how effective it is. And so we might do things like print debugging messages of some kind, like print here or inside this function. I do that quite a bit. Or you might run the same code again, hope it magically works now. That's like the most often used technique. And what's weird is that sometimes it really does seem to work. You might do some Googling search. And so if you look at what's on the first page of Googling, that's often you can find an answer, or keep on looking at several pages and do the 5th page. I don't know if y'all have heard about this technique, talk to a rubber duck. There's this concept in programming of often it's easier to debug something if you will describe the problem to somebody, like talk to another person and actually talk through what the code is supposed to do and what you're experiencing, and in that way try to figure out what the problem is. And so because there's not necessarily people around you that want to listen to you describe your program and talk about the error that you're getting, then the concept is that you would just talk to a rubber duck, and you still talk it out, but just that whole process of making your brain formulate the words to talk about the problem, even to a rubber duck, it can help trigger what the answer is. Or using breakpoints. If you've learned how to use an actual debugger tool, you can build breakpoints into your code and run it and inspect the different variable values at different points of your code. Read the docs. That's something that, according to this graph, we don't try as often as we should, but we try it sometimes. But look at how effective it is. It's definitely one of the most effective things to do is to read documentation. Using breakpoints is very effective, or even just taking a walk. We don't try that as well either, but sometimes just going away from our code for a while, doing something else, getting our mind completely off of it, and then coming back to it. Our mind has had time to kind of work it out subconsciously as to what the next steps need to be. But debugging, no matter how you look at it, is an important part of the programming process. And so with AI, we can learn to use these tools to help us speed up the process, but there is going to be no replacement for you still understanding the problem and understanding how to fix it. AI can help you get there, but it's not going to be the magic answer to everything. So the goal, of course, as we've been saying so far, isn't to let AI do it all, but it's to let AI help you become a smarter debugger. And so just a quick refresher of the types of errors that you encounter in programming. And I'm sure, again, if you've had at least one programming class, you're familiar with all three of these errors. The syntax errors are the ones where you've just mistyped something in the language itself, maybe left out a colon or didn't close your parentheses, or maybe even just misspelled a variable name. But all of these syntax errors, often when you run your code with a syntax error, then it'll give you an error message explaining that there's a syntax error. And sometimes it's pretty obvious just by reading that message, but other times it may not be. And AI can certainly help explain and correct syntax issues that you might not can catch yourself. Runtime errors are those errors that don't always happen, but depending on the input, when you're running the program, you may get an error. So for example, division by zero, if you've asked the user to input some numbers and then you're doing a division, and at some point the calculation results in division by zero, then that would crash your program unless you have trapped for that and accounted for that. So that's called a runtime error. It's an error you encounter only when running the program under certain situations. A file not found is another type of error like that. If you are working with files in your program, trying to open a file and you've given it a file name to open, if it can't find that file to open, then it's just going to crash and give you a file not found error. So again, AI can help you interpret those error messages and locate the causes. They can also suggest corrections of how to capture that possibility of a runtime error and how to more gracefully program around it and provide some what we call defensive programming for that situation. And then logic errors are definitely the hardest for us to debug, but these are errors that they don't usually crash the program, but it'll run and we get output, but the output that we get isn't necessarily correct. Or sometimes it might enter into an infinite loop, or just something else is wrong with the logic of the program. It looks like it should be working, but it's got something wrong. And AI is really good at helping us break down the parts of a program into situations that where we can better pinpoint what the logic error might be. And again, it's really good at suggesting corrections. So the role of AI in a debugging situation is, as we've been mentioning, AI can explain any confusing error messages. It can help you locate bugs, and it can suggest corrections. It cannot read your mind, obviously, and it also cannot guarantee correctness. It might confidently state a suggested fix, but it may or may not be correct, and you have to test it. It doesn't replace the testing that you have to do yourself of your program to make sure that any fix you implement is actually correct in all situations. Also, AI helps you learn from your errors more efficiently. So you can get AI to explain things, why this happened, how to avoid it in the future. And that is another thing that AI is really good at doing, and it's a good role to assign to AI in your debugging process. So prompting AI for debugging, obviously you've been getting better at prompting AI for different things, but for debugging, it's also important to be specific. So don't use weak prompts like just, why doesn't my code work? When you do something like that, you're leaving AI to just kind of guess what it's supposed to do, and it might guess wrong, or it might interpret the comments about the program wrong. And so you need to give it a little more information. And so this might be a better prompt. Here's my code, here's the error message I'm getting. And then you might ask AI to explain the cause, show a corrected version. And then it's even better if you tell it what the expected output should be. It's like, here's my code, this is the error message. I was expecting it to do this. Please explain, why it's not doing that, and show a corrected version. AI is good at explaining things. Try to ask it to explain what it's doing before it just gives you a fix. Don't let it just give you a fix that you blindly trust, because it may or may not be wrong and you're not learning as much in that way. So ask it to explain it before it fixes it, and then you could learn from that. And here's just a few more suggested prompts that you could try, and we'll be seeing some of these in our lab assignment this week. You might say, explain this error message and what it means. Or what part of this code might cause this traceback? And then, of course, you have to give it the traceback message. Or why is this function returning the wrong output? And again, there you need to also tell what output it should return, and you can't figure out why it's giving you the wrong output. Or you can say, help me find a logic bug. Here's what the program should do, and then give it your code. Or even get AI to show me how to test how to test the fix that it supplied step by step. AI is good at testing and coming up with some ways to test your program, and so it definitely needs to be tested after you've troubleshooted with AI. So I'm going to do a demonstration for you, similar to what you'll be doing in your lab in a little bit. Basically what I'm going to do is I'm going to run a script in Python that doesn't work. I'm going to get an error message, and then I'm going to paste the error message and the relevant code into some AI tool, and you can use many different ones for this. But then I'm going to ask AI to explain and propose a fix. I'm going to test its suggestion, and then what you'll do, of course, is reflect on what worked or didn't work. So let me switch over to a Python environment and start demonstrating this for you. Okay, so I have a program here in idle. So I'm just using a simple idle shell and script editor that comes with Python. And if you don't have this and want this, you can download it for free online. You just look for download Python and get the latest version available for your operating system and install it. And then idle, IDLE, is what will allow you to interactively work with Python, as well as create and write scripts and test and run them. And so I have a script totally written here for a program that is supposed to calculate BMI. So let me just work through this program with you briefly, and then I'm going to show you the few bugs that it has in it and how AI can help us debug it. So the first part, all of this is just kind of a comment that describes the program and what it's supposed to do. And so this particular program gets weight and height from the user. It calculates BMI and prints BMI along with the weight category. BMI stands for body mass index, and it's a simple calculation used to estimate a person's body fat based on their height and weight. not a diagnostic tool, nor always accurate, but it's often used by healthcare professionals just as a quick way to categorize weight status. And so our program is supposed to get weight and height and then calculate BMI. And so the formula that it's supposed to use is shown here. It's going to multiply 703 times the weight in pounds. So we're using US units, so the weight in pounds, and then it's going to divide that by the height in inches squared. And then that should calculate a BMI number. That number is then compared against standard ranges to determine a category. So anything less than 18.5 is considered underweight. Between 18.5 and 24.9 is normal. 25 to 29.9 is overweight, and then 30 or higher is considered obese. And so I've also got in this description just some suggested tests so that we can make sure our program is working correctly. So I've got several combinations of height and weight with the expected BMI and the expected category based on that BMI. So that's what's supposed to happen. Let's look quickly at what I've got in the program so far. I have a function definition called calc BMI that takes two arguments, weight and height, and then the doc string for that function tells us that that's supposed to calculate BMI based on the given weight in pounds and height in inches, weight in pounds, height in inches, and return BMI rounded to 1 decimal. And so then it has a calculation and a return statement. The next definition of a function is to print the BMI category. And this doc string says that it's just going to print the weight category based on the given BMI. And then we see this if-elif statement where it's testing BMI against the different ranges that were listed up above and printing or assigning the correct category based on the BMI numbers. And so we get category assigned to either underweight, normal, overweight, or obese, and then we print out that category. So those are the two functions that are doing the bulk of the work of the program. And then we have a main function here that's just going to test it, help test it for us. So this is simply asking the user to enter in weight and height. Then it's going to call that calc BMI function, passing it weight and height, and then coming up with a BMI calculation. It'll print the results of that. And then it's going to call that second function to print the BMI category. So that's all that the main function does. And then if you remember from your Python days, we usually in a Python program will have an if statement that's not inside of a definition just to be able to run the program if it's a standalone program versus if this program were included in another program as a module that was imported. But for this one, we're just saying if this is the main program, that it's not imported as a module, then we just want to run that main function, which is right here. All right, so that's the program. So I'm going to start testing it. And so I will run the module. It brings up the idle shell. Let me make that a little smaller here. And in that shell, we see the first input statement where it's asking to enter the weight. And so I'm actually going to move my idle shell down a little bit so I can see the test data above it in the program description I have. So here's some test data that I want to try. So I'll just start with that first row. The weight in pounds is 100. The height is 65. Uh-oh, so I already have an error. And so this particular error is a runtime error. It's something that happened while I was running the program. It crashed on me. And in Python, runtime errors do give you a message and then a little bit of help based on the line of code where that error occurred. So if you can look through this and figure out what the problem is, then you should do so. But if you kind of get stuck or can't quite figure it out, then this is how you could use AI in this situation to help with this. So I'm just going to copy the entire traceback part of the error message that it gave me. And then I'm going to switch over to an AI tool. And you can use whatever AI tool you want, ChatGPT, Claude, Copilot, or others. I'm using Claude here as an example. And so I've copied that traceback message into the clipboard or the memory. And now I just need to give it a little bit of information about what I want. So I'm going to tell it that I am writing a program that calculates BMI based on weight and height. I am getting this error. What could cause this traceback? And then I just want to paste in the entire traceback message that I got. So I'm thinking this would probably be enough for it to at least point me in the right direction. But if not, then I might need to also copy in a bunch of the code or even the whole program. So I'm going to leave it at that though, and then see what it might come up with. And so it does give me a message. It says the error indicates that weight and height are strings rather than numbers when you're trying to perform mathematical division. And then it gives an example of how it often happens and how to fix it. And so again, that particular error you may have been able to figure out yourself because it is one we run into a lot. But if not, this is how AI can help with the runtime error by giving it enough information from the error message that it can help you. And then it's going to suggest some things that may or may not be good. In this case, it's actually suggesting a really good thing. It's saying that I should go back and look at how my weight and height are being input and convert them to float numbers before using them in the calculation. So let me go back to the program and let me see where that is. It's in one of my windows here. There it is. All right, so I go back to my program and I want to look and see in this main function where I'm inputting weight and height, and I can see exactly that what AI suggested is what I need to do. I'm leaving these as strings when they're getting input instead of converting them to floats. So I'm going to do exactly what it suggested in this case. I'm going to leave each of these as a or convert each of these to float before I pass weight and height to the BMI calculation. All right, so let me test it again. Run, save. It's asking me again to enter the weight. I'm going to scroll up here so I can see some of my tests. All right, so I'm going to do a weight of 100, height of 65. Okay, so now it didn't give me a runtime error, but it tells me that if you are 100 pounds and 65 inches tall, then it's saying that you have a BMI of 540.8 and you're obese. So that obviously is not correct. It doesn't match the expected test results. And so now we need to do a little more digging and to figure out why this is not correct. So again, you know, the typical debugging method would be to go back and look at our program, look at where this calculation is happening in this function, and inspect it, test it. But if we do that for a while and we've tried different things and we're kind of stuck, this is how, again, we can turn to AI to help us with the debugging part. So let me go back and look at the message I was getting. Oops, let me go back. All right, so I am going to copy this, and then I'm going to go back to my, oops, not there. I'm going to go back to my Claude AI. and I can just continue in the same conversation or start a new one if I needed to. So I'm going to say, actually, let me back up. Look at what Claude did. I didn't even ask it to do this yet, but it said it did note an additional issue. And it said your formula has height plus height, adding height to itself. But for BMI, you should be multiplying or squaring the height. And it gives a couple of ways to do that. So that is something, if we had noticed that before, we may not have encountered this error that I just had. But because I think that is the fix that we're looking for. But if we hadn't seen that, or if it maybe a different AI tool wouldn't notice that issue, then what you could do in your prompt is again say my BMI calculation is incorrect for this data. And then you can just paste in what you had. But then I want to give it a little more information and say, here is my function where I am calculate, or I don't even have to give it the whole function necessarily. I can see here is my calculation where I calculate BMI, and then try to give it that code. Let me go back to that code. So I would want to give it just mainly this. And then let's see what it says. And hopefully it'll say the same thing it already said about the fact that height plus height should be multiplying. And so it looks real excited. The problem's in your formula. And then it tells what's happening, and it gives a suggestion of how to fix it, either using height times height or using the exponent operator in Python. So let me go back to the program and fix that. So it looks like I should instead have a star there instead of a plus. Then we can try running it again. And let me try the same input data. So 100, 65. Okay, so now the BMI is 16.6 and it's underweight. Great. So it looks like it's working. So we need to test it though some more. Let's see if I run across any other errors. So since I have this program written in functions, and I do have a main function that is calling these other functions, I don't actually have to go back to my script and rerun it. I can just keep calling that main function here in the idle shell. So that's what I'm going to do here. I'm going to say main, and it just starts it over with that main function. So I'm going to do the second test up here and see how that is. I'm going to do 150, 68, and it gives a BMI of 22.8 and normal. Good. Let me do another test. 164. Whoops. I'm going to do I'm going to skip that one because I want to do the exact data that's up here. So 164 and 68, and it says 24.9, and it should be normal. But mine is saying overweight. So I'm somehow telling it that 24.9 is overweight instead of normal. Because if we look back at what the categories said, the 24.9 was in that range of normal, but it was on the boundary of the range. And often those boundaries are what gives us trouble when we're categorizing data like this. And so it's a good idea to test all of the boundaries and make sure that they're putting you into the right categories. So we know that it's got to do with something, how we're categorizing the data. So I could just try to, again, go down to where I'm determining the category. And it's inside this function, the print BMI category. I could look at this if-else statement to see how I'm categorizing the BMI. And the one we were looking at was a 29.9. Let me go back up. That's not right. I was looking at 24.9, which should be the high end of normal. And so if I've traced through what's happening with this if statement, then I can see that I mean, it looks like I might have it right. I actually can see the problem that I have, and you may too. But again, if I wasn't sure, this is how we would go to AI to help us with this. So I would probably copy all of this and go back to our AI tool and say, okay, now I have a problem with the BMI categories. When BMI is 24.9, it should be normal, but it isn't. What could be the problem? And then I would give it the code, and I'd probably tell it that here's my code. All right, and let's see what it says. It's going to look at that and hopefully give me some helpful answers, but possibly not. Okay, so now it has analyzed the data and it says your code looks correct. A BMI of 24.9 should definitely fall into the normal category with this logic. And then it says the most likely problem is that BMI is a string, not a number. And if it is a string, then the comparison wouldn't work right. So it says to check the calc BMI function, make sure it's a number. So I want y'all to think about that. What do you think about that? Do you think that's a good answer or not? And then it's giving some more information about it. And then it says, if BMI is actually afloat and still not working correctly, please share your complete function and I can help diagnose further. So I'm going to go back to the code and do what it said first, which was to see if BMI is actually a number or a string. It was thinking it could be a string, and that's causing the comparison to be wrong. So if I kind of trace back what we're doing, we've got weight and height as float numbers. We've got the calculation of BMI up here being a number, and it's returning an actual number. And so then when we pass BMI to the print BMI category function, it's still a number, it's not a string. So that is it's not the problem. It came up with the solution or suggestion that actually is not my problem. It was saying that with this code, a BMI of 24.9 should fall into the normal range, but it shouldn't. It should be, according to our description up here, 24.9 should be normal, but our code is making it come out as overweight. Because when we tested it, remember, it said overweight. Let me go back and show you that test. So when we tested it here, we had a BMI of 24.9, but the category was overweight. So we could do more testing, but if we wanted AI to continue to try to help us with that, we have to go back and do what it suggests. It says it is actually afloat. It's still not working correctly, so we want to share the complete calc BMI function and see if it can help diagnose further. So we'll do that. Let me go back and do the complete calc BMI. I'm also going to, well, actually it just asked for that, so let me just do that part. So I'm going to give it what it asked for here. Here's the complete function. And then let's see what it says. Okay, and so it thinks now it found the issue. It said that the problem is in rounding does return 24.9, but comparing floating point numbers, which we're doing, there can be precision issues. And then it says, however, the real issue here is simpler. And then it says I'm using a less than to do my comparison, but that means BMI must be less than 24.9. But really what we are wanting to do is that a BMI of exactly 24.9 should still be, this condition should still be true for a BMI of exactly 24.9. So it says to use the less than or equal instead of just the less than. And then it gives this suggestion all the way through for these other categories as well. So that sounds like it's probably the right solution. So let's go back and fix that. And sure enough, we have less than here, but I want it to be less than or equal. And the same with this, I want it to be less than or equal. And then we can go back and continue doing some tests. So let me go back to run. And I'm going to start where I was on the 24.9. So 164, 68, 24.9 is now normal. Yay! And so then we can do more tests of these. The 30 happened to be another edge case. So I'm going to run it one more time just with that test data and see what it does. So 209, 70, 30, and obese. So that does seem to work now. So that hopefully gives you an idea of what it's like to use an AI tool to do some debugging and to be an interactive tool to help you where you go back and forth, fixing your program, testing it. Another thing that AI can do, and we may talk about this a little more later in another week, but it can generate test cases for you. So that's how I got these tests right here. I didn't just make up all the numbers. I asked AI to come up with a table of test data with expected outcomes. But I had to double check it. It wasn't doing the math correctly when I first looked at the table it generated for me. So I had to go back and tell it to recheck its math and to do it differently. And then it did, and it came up with a good table where we could test it. So that's something else that AI can help you do. So let me tell you more specifically, though, what you're going to do with the assignment this week. You're going to, let me go back into here. So you're going to do an AI debugging lab that's going to be similar to what I just did. You'll be working with the Python script that I provide here. It's a buggy Python script. It contains several common types of programming errors. Your goal is to use AI to find, explain, and fix each error while also learning to craft better debugging prompts. Even if you can already tell just by looking at it what the error is, I want you to still use AI to help you find it. So you're going to download this buggy debugging Py script from Blackboard. It contains 7 buggy scenarios, and you'll control which scenario runs by changing the value of the step variable at the top of the script. And so every time you change that step variable, it will run a different scenario. And then you'll download this worksheet here. It's a Word document that has a table in it, and I'll just open it up in here. Oh, let me download it. All right, so it's just a worksheet. Let me make this quite a bit smaller so you can see it. Okay, so the worksheet has a table already built into it. You're going to type your name and date at the top, and then you're going to fill in the rest of this table. So there are 7 scenarios in the script with a brief description of the function that relates to that scenario. And then you're going to look at each scenario, and you're going to try to see what's going to happen if you ran the program. And here's a prediction, for example, in the first one. The prediction is that it might crash if divided by 0. And then you're going to run it and actually see the message or problem that you got. Then you're going to use AI to try to help you find the reason for that error. And you're going to record here the prompt that you use. Then you're going to give a brief summary of what AI suggested that you do. You're going to record what your final fix was to fix that error. And then, yes, whether it worked or not, or you might even need to describe, it worked in some cases, but not others. But you're going to fill out a table row like that for each of the 7 scenarios. And some you might have a lot more text in than I do in this first example. So what you'll do then is you're going to be testing that script, and you can test it, by the way, in any Python system that you might be familiar with. Obviously, if you've downloaded Python and it's on your computer, you can use the idle environment that comes with it. You can use VS Code that you may use with other languages as well. You can use Replit Online, or another online option is online-python.com. Those just give you some free interactive editors that and IDE environments that you can type up and run a program in. But you need to download the code and then inspect it for each scenario, run the code, use AI to diagnose the problem, apply and test the fixes, and document your results. And so you'll spend some time doing that for all 7 scenarios. And at the end, then you'll add a short summary of your experience at the bottom of that worksheet, addressing these questions. And then you'll turn that in along with the corrected Python script from the debuggy one that we started with. You're going to correct it and try to correct all those errors. So you'll submit both the worksheet that you fill out and the corrected Python script as your submission for this assignment. And so the goal, again, is just to get used to what AI can do or not do, or just how it can work as a partner with you in helping to debug your code. Now, let me just point out a couple more things from this PowerPoint presentation before I let you go. So we did this in the sample that I did with you. You do need to verify AI's suggestions. Don't just trust it blindly. If I had taken its first suggestion as to that BMI was a string instead of a number, then I might have really confused it more trying to fix that error. So don't always trust it blindly. Test it after each fix. Compare its fix with documentation and logic. Make sure it still does what it's supposed to do. And then don't forget, you can ask AI to explain as much as you need to why a fix works. And what I do sometimes too is I'll even say, then what could cause this to not work? What kind of problems could there be in the input that we haven't experienced yet? And it's sometimes pretty good at suggesting some of those as well. Just a reminder of some ethical and academic integrity considerations. Use it as a partner, not a cheat sheet. Always understand and verify your code before submitting it. Acknowledge AI assistance when appropriate, and it's fine to do that. Say, AI helped me do this. And then protect private or proprietary code. So you don't want to ever give a public AI your complete code if it's a proprietary code that you're trying to protect. This again just tells you about the lab that you're going to do. Key takeaways I hope you get from this exercise is that AI can save time by explaining and locating the bugs, usually quicker than we can by staring at it. It'll help you understand that the fix is your responsibility. It just helps, but it still may not be right. It's only as good as your prompts and verification. And it's a skill that like everything we're trying to do in this class, we're just trying to give you exposure to these skills, give you some practice and reason to try to develop some of these skills of using AI as a programming tool. So let me know if you need any help with that debugging lab. And I do have a little more, like I said, that I'll have you do later in the week. that won't be due Sunday, but we'll start it later in the week. All right, thank you.